Alright guys, so I left off on this slide right here, just talking about inherited disorders that can be controlled by just one gene. Remember, like I said, not all disorders and all traits are only controlled by one gene, but teaching genetics is easiest to teach by first explaining genes or one gene to a disorder or one gene to a trait. In a couple of slides, probably on my next summer science day, I'm going to explain some of the different other types of inheritance patterns and how they don't always follow like plain old dominant recessive, and how it's not always just one gene contributing to an inherited trait, but actually several genes. So I left off telling you about all these different incidences and kind of explaining how if you look like for cystic fibrosis, for example, it infects 1 out of 2,500 Caucasians. Phenylketonuria, so the one where they can't break down phenylalanine, that affects 1 in 10,000 people or births per US and Europe, and kind of where does that come from, and I'll talk about that in the next couple of slides. So let me get this little box of me out of your way. Okay, so the table on the previous slide, all this is kind of stuff I've already said, but that table is showing you things that are basic, normal, dominant versus recessive inheritance and only controlled by one gene. And all of those disorders that you saw in that table also are only going to be found on the autosomes. So those disorders do not affect genes or do not come from genes that are found on the X or the Y chromosome. Okay, that's what the autosomes are. So most human genetic disorders are recessive. And the reason for that is because the reason why there are more recessive disorders is because there are tons and tons of carriers that don't know they have it until they marry and have kids with someone who then also had that recessive trait, and now their children have it. So the reason why recessive traits are so much more, or recessive disorders are so much more prevalent than dominant disorders, there are dominant disorders, but the reason why most human genetic disorders are recessive is because of the fact that you can have a carrier. With a dominant disorder, you cannot have a carrier because if they have one copy of that allele, then boom, they have it. They do range in their severity. So, for example, being albino, it's not going to kill you. However, Tay-Sachs will kill you. So they can be harmless and not so harmless. Most people who have recessive disorders are born to carriers. The parents had no idea that they carried this potential to have this trait. And that was one of the questions, too, that I had on your final. And I did. Most people got it right, but I had given you enough information about cystic fibrosis for you to be able to answer the question about would there be a possibility that if I was also heterozygote, aka a carrier, what was the percentage chance that Matt and I's kids would have it? And we really just apply the rules the same way for carriers as we would in a normal Punnett square or a pedigree, but instead of just, look at Khaleesi. But instead of just calling the heterozygotes, instead of just saying, oh, they show like the normal phenotype, we call them carriers. And then in this case, since we're looking at a recessive disorder, if they're homozygous dominant, they don't have it. If they're homozygous recessive, they do have it. In this case, we're looking at a particular type of deafness. Surprise, fun tidbit, there are actually several different ways that you can be deaf. There are different levels of deafness, and there are different reasons that people become deaf. One of those reasons is exposing yourself to really loud noise all the time. So you people that like to listen to your AirPods on all the way up, you're literally spelling out a recipe for being deaf in your 50s. Because the cells in your ear that are responsible for your ability to hear sounds, they're called hair cells, which is really inconvenient that they're called hair cells because they're not hair, they're just cells found in your ear, but they look like little strands of hair under the microscope, so we call them hair cells. those, once they're dead, they did. They don't undergo mitosis. So once you destroy those cells, they no longer work. If you destroy enough of them, you're deaf. So just think about that. The next time you listen to your music really loud, or when you go somewhere and they have music really loud, i.e. prom and winter formal and all the other dances, if you're standing close to the speakers, you might notice that when you leave, you have a ringing in your ears, or you feel like you're yelling at people because you can't hear very well. That's because your hair cells are basically they're being traumatized and they're trying to recover from and not die. So you can recover them to a certain extent, but they don't divide by mitosis. So once you kill them, they're dead. So keep that in mind when you listen to really loud music. So cystic fibrosis. So basically it is going to have a recessive inheritance pattern. 1 in 31 Americans carries this allele. So they're 1 out of 31 people. So there's 106 people that were in your class. So that's quite a few people who are carrying the trait. Even if they don't have it, they're carrying the trait. If you have 2 of those recessive alleles, then you are going to have the disease. And like I mentioned earlier, it causes a thick mucus to be secreted in the lungs, which makes it difficult for them to breathe. There have been lots of advances in medical treatment, like cystic fibrosis. Like when I was little, if you knew of somebody who had cystic fibrosis, they were going to die in their teens. But now they can live to be 30, 40. They can live a really long time because we've come up with some really good treatments for breaking up that mucus and stuff like that. But still, it is genetic and it does follow the recessive inheritance pattern. So that thing about different populations having a different incidence of the disease. So this is when you have disorders that are not distributed equally amongst different populations. So, for example, cystic fibrosis is way more common amongst white people, whereas sickle cell anemia is way more prevalent in black people. And the reason for this is because of this lovely thing we call geographic isolation. So you all know what geography is, and you all know what isolation is, especially since coronavirus. But what is geographic isolation? So for hundreds of thousands of years of human evolution, we didn't have boats, we did not have trains, we did not have planes, and we did not have cars. Do you know what that means? That means you got married and had children with people who were in your area. It's not like people could travel around the world making babies with people of different traits. You basically had the option of the people who are around you. Now, the thing with that is if you have the allele for cystic fibrosis and you've been in the same population for so long that there are also a lot of other people around you that carry the allele for cystic fibrosis, it's way more likely that you will have a child that has cystic fibrosis than someone on the other side of the world who is in a different population where they don't have a lot of carriers of cystic fibrosis. Sickle cell anemia, same thing. The reason why it's more prevalent in black people is because for hundreds of thousands of years, you got sickle cell anemia, and then it actually turns out that malaria, which affects people in Africa where the mosquitoes actually carry the parasite malaria, if you have sickle cell anemia, malaria does not affect you as much as it would affect someone who doesn't have sickle cell anemia. Whoa, that's cool, right? Exactly. So the people who actually had sickle cell anemia, had that sickle cell trait, they were more likely to survive long enough to reproduce with someone else who was more likely to survive long enough to reproduce because they have that sickle cell anemia. Whereas malaria, before we had all these anti-parasitic drugs and stuff like that, malaria was kind of a death sentence. That parasite ended up killing you sometimes before you were old enough to reproduce. So the reason why African Americans are more likely to have sickle cell anemia is because they had at one point a genetic advantage against malaria by having sickle cell anemia. And so people who lived long enough were the ones that had sickle cell anemia, and they mated with other people who lived long enough to be able to have babies, and then their kids had sickle cell anemia, and it had a great genetic advantage for them. And because, again, of geographic isolation, hello, there is an ocean in between America and Africa. There's literally an ocean, right? So there was no crossing it. So it stays in populations. On the other hand, this is why inbreeding is bad. This is why incest is bad. Honestly, the only reason you think incest is bad, and by you I mean us, the only reason we honestly think that is because society tells us it's weird, right? If no one ever told you something was weird, you don't know. But anyway, it is actually genetically bad to have incest or inbreeding, not just among humans, but also among animals, puppies from the same litter being bred together. Not nearly as horrifying to think about, still not good, because you're basically taking what we call the gene pool and you're constricting it. You're making it really tiny. If you only have the alleles for bad traits and you're mating with someone else who has all those same traits, then every time you're going to get the bad traits. Every single time those two have kids, they're going to have those bad traits. One example is the, you can look it up. You can look up the hemophiliacs in the, I think it was the English royalty. They all had hemophilia, which is a bleeding disorder where when you cut yourself, your blood doesn't clot and you can bleed out. Very terrifying. Well, they were trying to keep their bloodline pure, and so they had children and cousins all have marriages, arranged marriages and children, and all their children were dying of hemophilia, or they all had hemophilia. Why? Because if you only have that trait and you're only giving them the possibility to mate with someone else who has that trait, all of those offspring are going to have that trait. So that's why incest is bad, and that is why we have different incidences among different populations, because of that geographic isolation. My phone's ringing. Hold on. Okay, so we left off with me going to answer my phone, and now it has been 4 hours, and we went to the grocery store, and I kind of forgot where I was. Basically, there are also dominant disorders, which are going to be genetic disorders that occur when you only have one copy of the allele, right? Because it's dominant. And so if you have a dominant and recessive true Mendelian type of inheritance, then you know that you only need one copy of the dominant allele to show the trait. A number of human genetic disorders are dominant. They're less common than recessive disorders, but they do happen. Some are harmless, like if you have extra fingers or extra toes, that's called polydactyly. Or if you have webbed fingers and toes, those are things that are caused by dominant traits. However, they're harmless. There's no problem having an extra finger or an extra toe. A lot of times, basically, you'll have a surgery when you're an infant. They'll remove the extra finger or the extra toe. No problem. And even if they don't remove it, still usually not a problem. Some are not harmless. One example is achondroplasia, which is a type of dwarfism where the torso and the head of the body, where our short bones are, surprise, you have short bones and long bones, but the short bones develop normally, but their long bones, like their arms and their legs, are dwarf. They don't grow as much, they're short. If a fetus is conceived as a homozygous dominant, that is considered a lethal combination of genes, that is lethal alleles. If they are homozygous dominant for achondroplasia, that baby is spontaneously aborted or miscarried. A spontaneous abortion is the medical term for a miscarriage. If an individual is heterozygous, that means that they are affected, so they will have achondroplasia. So they're not a carrier, okay? They're not carrying it, they have it because it's a dominant disorder. But the heterozygous individuals are going to be the ones that have the disease, and they obviously have a 50% chance of passing it on to any offspring because they have one copy of the dominant allele. Therefore, most of the population, like aka almost every single person you know, if not every person you know, has homozygous recessive. We do not have achondroplasia. And so I'll pick back up on there on the next one.